So in this video, we're going to learn how to solve systems of equations by graphing. Systems equations is kind of like a brand new topic for us. There are three methods to solve. Each one kind of has their own advantage, so it's to your advantage to know all three, and you will be required to use all three on the upcoming exam. So here are your objectives: that you can solve a system of linear equations by graphing, and then you can state situations when solving systems that have one, many, or no solution. So why do we need systems of equations? Well, here's an example that you would use a system when you're comparing two cell phones company, Verizon and Sprint. Now Verizon charges $40 a month, plus they charge $5 per gigabyte. Okay. And you would use this equation to figure out your total cost, or what you owe them. Where Sprint charges $25 a month, plus $10 per gigabyte, and that will give you your total cost. So if you're looking into these two companies, it'd be important to know which one would be cheaper for you, and you can also figure out when they're going to be the same. Now right now, probably what you could do is just kind of a guess and check method, trying to figure out different values for G that would get the two the same. And it actually turns out after 4 gigabytes, the two companies would be the same cost, and then at that point, Verizon would be the cheaper option, where notice Sprint, since it's only $25 initially, would be your cheaper option at first. So systems of equations, what it is, are two or more lines. We are going to only deal with two, but you could have more lines. So you have two lines on a grid, which goes off our linear we just did. Now most lines, you will see that they intersect. And what we're actually doing when we're solving the system of equation is we're trying to find this point where the two lines intersect. So because of that, we can have three possible solutions. We can have two lines like I drew above, and they would only have one solution because two lines only intersect at one point. Or they could have no solution. So if you think, okay, what type of lines would have no solution? Well, they would not have to be, they cannot intersect. So these lines would be parallel to each other. They would, parallel lines, remember the definition from your previous years, are two lines that do not intersect. Or many solutions. This one's a little more confusing. If you have a line and you want the lines to touch more than once, well, these two lines have to be the same line. Therefore, they're intersecting the entire time. So there's many, or infinite amount of points that these two lines intersect. We're going to have all three of these situations come up with our examples. So solving a system by graphing. So pretty much what you're going to do, you're going to graph the two lines and find where the intersection point is. So you have your first line, which I'm going to draw in blue. So remember, you have your M and your B, your y-intercept. So I'm going to start on my y-axis at -3, and then I move by my slope. It's 2. We put over 1, so we have a run. So I rise 2, run 1. It's very important when you're doing these to do as many points as you can on the grid. It just kind of helps you make a more accurate graph and to really make sure you find that intersection point. Okay. Draw my line as straight as I can. So that's my first line. So now I'm going to draw my second line in red here. So we have -1. The slope, the number in front of x, it is 1x. So it's 1 over 1. So we're going to go up 1 over 1. You can probably already see the intersection point. And since I already have it, I'm not going to do all of my points. Drawing my line. These two lines intersect at this point right here. So my solution to the system, the point that they have in common, is 2, 1 over 2 up 1. Right, so one more example like that. So I'm going to graph my two lines. So I'll graph my first one in red. I start at +5. 1, 2, 3, 4, 5. That is my y-intercept. And my slope is 1. Because slope is always next to x, so it's 1 over 1. So go up 1 over 1. Like so, and again, the first line you really want to try to get as many points as you can. Your unsure what that second line is going to do, where that intersection point might be, what point the two lines have in common. Draw my line as accurate as I can. So in this one, notice we don't have plus anything. Well, it's plus 0, so it starts at the origin. And I go down 4 over 1. Or I'm going to go up 4 because notice that's the direction of my line. And right there was my intersection point. I don't need to do too much more. Alright. So my two lines intersect at -1, +4. So these are kind of special lines. If you look at the first one, we just have y equals 3, and it's kind of like, oh, something is missing from this line. So you have to think to yourself, what is missing? Well, you're missing the x. So what I want you to do, it kind of helps you graph, because students get confused of what these lines look like, is doing a table of values. So I'm going to do a table of values for y equals 3. So it tells me y is 3. That means my y coordinate on any point on that line is 3. And then I can just pick any x value I want. So I have 0, 3, 1, 3, 2, 3, and 3, 3. And notice, if I keep going kind of with that pattern, this is a horizontal line. So then on x, again, notice we're missing the y. So we're going to do a table of values. So in here, x is -2. So I'm going to fill, just like with the y, the x column with -2. And go 0, 1, 2, 3. So I have -2, 0, -2, 1, 2, 2, and 2, 3. So then I'm going to graph. Well, my point of intersection is at -2, 3. Now some of you might be on your toes and kind of notice something about these two equations. Before I actually even start, it gives me the solution. Look, the x is -2, which is our x coordinate, and the y is 3. So this system was actually solved for us before we even started. But this is what it would look visually. It would be a vertical and a horizontal line intersecting at -2, 3. So on D, I'm going to graph these two lines. I'm going to start at +1. Now it's -1 over 1. So I'm going down 1 over 1. Again, that first line, try to get as many points as you can to try to get these two lines to intersect. It's changing my direction on my slope. Trying to find that intersection point or the point they have in common. Alright, so then on my second line, I'm going to start at -1, and it has the exact same slope as the first one. And notice these two lines are mirroring each other, or they're parallel to each other. They're never going, if I draw it straight, to intersect. So since there is no intersection point because the lines are parallel, we write no solution. There is no point of intersection. And you might have noticed the reason for that are the slopes. When the slopes are the same, two lines are parallel because they're moving at the same rate. Alright, so on this one, if I'm going to graph the first one, I'm at -1. My slope is -1/4, so I'm going to go down 1 over 4, up 1 over 4. So Then I'm going to graph my second line. Well, this line also starts at -1. And notice it has the same slope, -1/4. It's just the equation's rearranged. So what's happening on this one is that these two lines are the same. Well, how many times they're touching? Well, they're touching many times. They have many points of intersection. So we write many solutions. So that concludes solving systems by graphing. So really you're just finding the points of the intersection of the two lines. Just graph the lines and find out where they intersect. Remember, they could have one solution if they only intersect once. They have no solution if they're parallel. If you have parallel lines. Or many solutions when they are the same. Just a reminder, make sure you do your reflection so you have credit for watching this video.